Welcome to another session on ASPICE for cybersecurity. So today we will talk about Sec 2, cybersecurity implementation. Maybe in the beginning, I'll take a couple of minutes to brief through what is the purpose and what are some of the best practices which are identified in this process, and then we'll slowly move into a bit of a deeper discussion. So I have a standard in front of me, and when I look at the purpose of this process, Sec 2 cybersecurity implementation, the purpose is to allocate the cybersecurity requirements to the elements of the system and software and ensure that they are implemented, which means it is more or less talking about the complete life cycle until the development. You start from the requirement, then go to the architecture, then go to the implementation, but also keeping in mind that you have a system level, you have a software level, maybe also the hardware level, and so on. So it is given in the bit of a higher level. What are the base practices? So the first base practices talks about refine the details of the architectural design. We will also go in the later stage a bit deeper into what this is and what are the different notes given there. We'll analyze it. Uh, BP2 is allocate cybersecurity requirements, which is more or less describing allocating the requirements which we derive into the different elements of the architecture. But here we have to be careful again, as I told, since it is a very generic statement, we have to apply it to different abstraction level at the end of the day. If in the system level, I'm talking about the system requirement, then I have to allocate those requirements to the respective elements in the system architecture. Similarly, in the software level and also in the hardware level. Base practice 3 is about selecting the cybersecurity control, which means if at all we are deep in this particular domain in the cybersecurity, we always come across these terminologies: cybersecurity specification, then comes cybersecurity controls, which means cybersecurity specification is more about what to do or what should be accomplished, and the cybersecurity control is more about how am I going to implement that particular thing. So which means the base practice 3 also talks about how do I choose appropriate cybersecurity controls in order to fulfill the cybersecurity requirements, and also, or in other words, also to support the cybersecurity requirements. Then the BP4 is about refine interfaces, which means at the end of the day, whatever the interfaces we identify and define, we have to keep regularly keep reviewing it if it is still relevant, if it is outdated, if there has to be something new to be added, or if something has to be updated, etc., from the security perspective. So this is talking about the BP4, and the BP5 is about analyzing the architectural design, which is more with respect to analyzing or identifying the vulnerabilities. Then there's a BP6, which talks about refine the details of the detailed design. So it's once again giving a bit of a hint that it's not that one time I create detailed design, but I have to keep on refining it based on the project life cycle, because sometimes I will add certain functionalities, maybe later in point of time because of some changes I have to remove it, because of the change request I have to add something else. So we have to keep refining it. And the BV7 is talking about develop the software units. So here, once again, we have to keep in mind, since we are talking about ASPICE for cybersecurity, we are mostly talking about developing the software units which are cybersecurity critical, or which would, let's say, support the implementation of the cybersecurity controls, in return support the fulfillment of the cybersecurity requirements. And the BP8 is about establishing the bidirectional traceability, which is pretty common when we compare with the ASPICE 3.1. In almost all the engineering processes, we come across this particular base practice. Then comes the ensure consistency as a BP9, which is kind of coming bit together. In one of the earlier videos, we have discussed a bit deeper into how do we ensure the consistency and what are the things we have to consider. Viewers can also refer to our earlier videos. And in BP10, we are normally referring to communicate agreed results of cybersecurity implementation, which is also almost in line with ASPICE 3.1, where normally in most of the engineering processes you see that communicate as one of the base practice where you develop certain artifacts, you create something, and you have to communicate it to the respective stakeholders so that they can make use of it and continue with their work, or they can refer to it and make certain decisions for the cybersecurity critical activities. So colleagues, in a nutshell, that was the purpose of the process sec 2 cybersecurity implementation, and those were the 10 base practices which we recently identified. So Falgun, your initial impression.
Yeah, so if you ask me regarding sector specifically, I think this has a very important role in the cybersecurity processes. Out of the four, I would probably rate it as the topmost priority. Again, it is my personal view. The reason being, Sec 1, you are going to define your requirements. However, in Sec 2, this is where you are going to realize your requirements into the actual activity. As you rightly mentioned, in terms of BP3 that you described, select cybersecurity controls. So this is where the requirements are turned into an implementation. Like, what are the mechanisms? How do you realize these requirements? What kind of methods are you going to use? Are you going to use a third party component to secure your software? Are you going to use inbuilt some crypto mechanisms? Do you need hardware mechanisms? So these are the most critical things that would come along in this particular process. So this is where I feel that this has a lot of importance and benefits in terms of defining the guidelines for building a cybersecurity or a secure product, I would say.
Hmm. Okay. Uh, that said, maybe we'll go a bit deeper into each of the base practices and try to see what are the hidden things. Of course, there are certain things which have been written, but it is not that straightforward because we already told that this particular standard also doesn't really worry about the different abstraction level. Yeah, it talks in general about the cybersecurity architecture and implementation requirements and so on, but we need to decipher what it makes, in which way it makes sense in the system level, how do we see it in the software hardware level, and so on. So the base practice one, as I already told, is about refine the details of the architectural design. And the description given here is the architectural design is defined based on the cybersecurity goals and cybersecurity requirement. And there's a note which says requirement could be on system and software level architecture. And refinement here means to add, adapt, or rework elements of architecture. So my question here is, if at all I'm the one who has to let's say use this particular base practice, I'm responsible for maybe it's a cybersecurity critical product, and I'm a, let's say, a system architect. How should I see this base practice?
Okay, so my understanding from this best practice is that like we are refining their architecture, and if any person is for the system level, so there could be system architecture for any ECU or any product developed without cybersecurity aspects. So the same architecture can be refined to incorporate the cybersecurity uh, mechanisms or cybersecurity implementations, and that maybe that's what is about this BP.
Hmm. Yeah.
So that actually, it's a very good explanation, Ronak. So that brings me to a very interesting question, which is a common myth in the industry. So here, as note one mentioned, it says refinement could be done on system or software level. And Ronak, as you mentioned, so you have a system architecture or a software architecture, and you got a cybersecurity component, and then you would want to refine it, right? Does it mean that safety or security? So I'm also bringing in safety here for the sake of completeness, but does it mean that security components can be considered as an add-on to the existing product?
It depends maybe what we are adding for the cybersecurity. For example, now like if you just consider one example, I uh, had bootloader and application and so on, and we were doing the flashing, but previously there was no security related things in the flashing and so on. But now if I say maybe I have to implement secure flashing, for example, now this depends. Maybe I have to change the hardware, I have to change the complete software or so many things in the software. This could be, I mean, very large change, or sometime it could be maybe less change. Like maybe if I just say I have secure communication, which is like implemented over a SecCosi and so on in the Autosar stack. Previously, there was no SecCosi PDUs, and now maybe I'm getting SecCosi PDU. Then maybe I can integrate just this SecCosi modules in my software, and we can adapt the architecture. So this maybe would be the small change, but it depends on what kind of change we are talking about.
Right.
Mm.
So I think you mentioned two, you categorized the whole thing into two sections. So one section being a major chunk of change which will revamp the complete project. And the second chunk is where, there's a smaller addition where it is much easier to get things integrated. So that's the very, very good way of, bringing those 2 points. So one thing I would like to probably throw some more light on is if we are trying to get to a stage where there is a complete hardware change the way you explained, this is where analysis needs to be performed, and probably uh, the myth of saying that okay, I have a project, um, I'll get the concept established first and then add the security component may not actually work in this situation. The reason being, if your hardware is messed up because of the environment, or your hardware does not support the right components, in this case what Ronak you mentioned, the bootloader part of it or the security part of it, maybe you would need a HSM. So this is where teams tend to do a lot of or undergo a lot of complexities in the architecture. So this is where this is one such situation. So any tips, Praveen, do you want to share with in this scenario?
Okay. First of all, we have to understand that security shouldn't be taken as a separate life cycle compared to your original life cycle of the product, which means it's not that first I will develop a product which where I don't really think about the security features at all, then I try adding, maybe I go back and add the requirements, refine the architecture, add the implementation. This is not an optimal way of doing it, and nobody should try it. Rather, what has to be done is, because we also understand that security is also kind of a V model. There is a requirement, there is an architecture, then goes to the implementation. This has to go hand in hand. So this is where if somebody is thinking, okay, here whenever I say refine the details of the architectural design, which means I already had an architecture which is not at all security critical. Now I am refining it. Maybe based on that architecture, I already have a product ready, and now I'm refining it to bring the security parts or security features in. That's the wrong approach. I think we have to make it very clear that we are not talking about that. Rather, we are talking about this phase where you have an architecture defined. Along with that, you also consider the security aspects, and based on that, whatever the input you get from the higher level, maybe it could be cybersecurity specification at the system level, or it could be some of the security inputs you get from the even higher level, like cybersecurity goals or item definition or whatever it may be. then you are already refining this architecture before you make further decision lower in the V model. It could be with respect to your software, it could be with respect to your hardware component selection, it could be with respect to how do you want to design your software architecture, where do you want to procure your modules from, what kind of coding styles you want to use, etc., etc. So here we have to be careful. We are mostly talking about refining an architecture with respect to the security feature even before I go further down. Yeah. So what is the tips here? What it is to go with the proper approach of doing it, instead of thinking that okay, maybe initially working on the security parts or security related features could be expensive, takes more time, maybe there is a lack of know-how, or maybe thinking it is not at all required, doing something without considering it, then going back and redoing, reverse engineering everything, refining everything, which is a lot of effort, lot of time taken, and maybe sometimes we may come to a place where we see that okay, it is not at all working now, maybe this is not at all possible, maybe I should have made certain decisions already. So this is where I think the project teams have to be very careful, which means at the end of the day, once again, we are coming back and talking the same thing, having certain awareness within the organization, having certain process within the organization, which states that, hey, dude, please do not develop a product and then try to make it security critical, rather develop a security critical product in one go. That should be the, theme of the development.
All right. So just to summarize, or maybe in a nutshell, if we have to add on, let's say a situation where the OEM pushes that now we have a product, but next year I'm not able to release the product. So because of the standards or European Union guidelines, I need to make it security compliant, and they bring in new set of cybersecurity requirements to your product. Your tip is that consider this as a separate project, because you cannot integrate cybersecurity to an existing product. This is not the right way of doing things.
Yeah, in a sense, I wouldn't say you cannot integrate. Rather, I would say it is not a best approach, because in this case, because we had also seen certain projects in the past where maybe if in 2015, if at all you talk to automotive suppliers or automotive OEMs, maybe security was not really at the highest priority. So this is where there were let's say products which were developed but not having too many security features in mind. Maybe today the same products are getting upgraded to meet the current existing compliance. What does that mean? That is more like I'm developing another revision or another version of the product, which is again like new project, where of course you can use the experience what you had so far, but you have to reevaluate everything. And definitely it is kind of a change request where you really have to evaluate all the phases and see what I can reuse, what will change, time, effort, and everything. So it's literally like a new project, as you mentioned. Any questions on that? Next. Yeah, so the second base practice is about allocate cybersecurity requirements. So which more or less talks about you know allocating the cybersecurity requirements to one or more elements of the architectural design. Cybersecurity requirements could be on a system and the software level.
So here, in my understanding, what you're trying to do is at the sec 1 level, you would have defined your cybersecurity requirements, probably detailed it out much deeper level, saying that okay, these are my cybersecurity requirements that my product, if it is at the product level or software or system, needs to achieve. So this is something that you would allocate to different units. So when I say allocate to different units, so at the first iteration you would already have one version of architecture. um, Now you are trying to see if those units can handle these cybersecurity requirements, or do you have to add new units or new components in order to meet this cybersecurity requirement. So this is what you would want to do. So this is where you would allocate and find out in your existing architecture what can be done, what needs to be changed.
Mm. But having said that, it's bit, it's a little bit interesting why this is a BP2. You see, normally if you think about allocate cybersecurity requirements, I'm talking about cybersecurity requirements I have here. I have a cybersecurity related architecture here. I'm allocating the requirements from top to the lower level, right? But if you see the base practices, base practice one says refine the details of architectural design, and the base practice two talks about allocate the cybersecurity requirements. The
I
reason
think
is,
he.
Mhm.
Mhm. So
Go on,
what I
Dharmesh.
think is, let's say you have project which you initially designed the architecture for system or software, and then comes the cybersecurity requirements from the Tara.
Mhm.
For an example, let's say you have Ethernet communication, and then the requirement comes that it shall establish the Ethernet firewall. In that case, you do not have suppose switch component in the architecture. In that case, first you have to define, include that Ethernet switch in the architecture, and then that requirement shall be allocated to this component. I would say that's why it's in this way.
Exactly, which literally means that if there is no architecture, then there is nothing for you to allocate,
Mm,
right? So that's why it's even though it looks like okay, allocate the cybersecurity requirement should be happening first, then the architecture. It's the other way around. First you prepare architecture, then you bridge between these two requirement and architecture. Any other remarks on this base practice? Okay, then we'll go on to the third base practice because this is something interesting and I have some questions on this. So this is about select the cybersecurity control, which says select appropriate cybersecurity controls to achieve or support the cybersecurity requirement. Okay. Now, if I think about this particular base practice, are we saying that this particular base practice is relevant for all the abstraction level, such as system, software, hardware, or are we of the opinion that it is only relevant for maybe software and hardware, but not for the system? How do I make that decision?
I would say it's majorly depend on the requirement. So once the requirement is analyzed and comes to the, let's say, architecture person who is designing, then he has to decide whether this requirement is related to or can be solved with the control which we allocate only for the software,
Mhm.
or let's say you need the hardware. If let's for an example, if crypto needs to be designed, then for that crypto to storing the key, we need the SDA or HSM module, and the separate hardware is needed.
Mm.
But if we say decide that it will calculate the key within the software itself, then it can be also designed in the software level. So I would say it's depend on the requirement, but it will be applicable for all system, software or hardware.
So that said, maybe a follow-up question. If I understand the explanation correctly, even though in the system level I choose a control in order to implement certain cybersecurity requirement,
Mm,
at the end of the day, this control is relevant at the software level or at the hardware level. Did I understand it correctly?
yes, that's correct understanding.
So, which means even though for the sake of saying it, I have a control identified in order to implement maybe, for example, a system cybersecurity specification, it is not really implemented at the system level. When I see abstraction, of course, system
Mm,
contains software, hardware, and everything, then
mm,
it means it will be allocated to either I implement it in software, hardware, or maybe both sometimes. But there is
mm.
nothing to say like, okay, some control which is just system relevant, but may not be relevant in the lower levels. Is that a right understanding?
Yes, that's correct.
Falgun, any remarks from your side, or did you
No,
understand my question correctly?
mm,
It could be a bit confusing,
just
but
to
whenever I
reiterate here.
say only system, not hardware and software, I'm just thinking like the abstraction perspective. But of course, at the end of the day, we know system is not independent. Of course, it is made up of software, hardware, mechanical, and whatsoever. Yeah, please.
Right. So just to reiterate your question, to summarize, to give a one more turn to to understand this question. So it is quite clear that system cannot be all by itself. System is broken down into hardware, software, mechanical blocks or units, right?
Mm,
However, what you're trying to say is, let's say if you define a concept, cybersecurity concept at your system level, then it will not be or it cannot be completely done only at the system level. There should be something at the software, hardware, or both.
mm.
So finally, the implementation happens at the software or hardware. And this is where the allocation will get there. And technically, in that way, if you say this particular BP3 would mainly be relevant to your probably either software or hardware or together software and hardware. This is what is your question.
Yes.
Um, it's a very complex question, so it is very hard to give a binary answer whether yes or no.
Mhm.
On the lines of points that Dharmesh mentioned, so you have a cybersecurity concept at the system level, you would inevitably have to implement that either in the software or hardware or combined. Now, let's say there is a cybersecurity mechanism which involves both software and hardware. Now, this is where software will get a certain version of the cybersecurity concept or certain part of that cybersecurity concept allocated to the software, and the hardware gets the other part of it. Now, this is where it becomes tricky. We are talking about still the left side, defining the cybersecurity concept. However, what I also want to underline here is this left side also has a horizontal traceability towards the right side, right? So that means in order to verify this cybersecurity concept as a whole, you need to have an integration test case. However, when you are at the software or the hardware level, the cybersecurity concept has already been disintegrated. Let's take the example of making sure that you have a crypto. The crypto uses hardware and crypto uses software also. There is a crypto software module and there is HSM. Now, the functionality that you are going to test what HSM needs to do at the hardware level is different compared to what your software needs to do at the software level. However, in order to protect your system and finally protect your product, at the system level, the functionality when it gets combined would still be something different. So, this is where my answer would be that this particular base practice would still apply to all the things. The reason being, when things get integrated, the overall functionality gets achieved.
Mm. Um, okay, so coming back to this particular base practice, I think this one would apply because once again, when I read it, it only talks about select cybersecurity control, not implement. So which means I was mostly talking about implementation, but selection, of course, in the system level also I have to choose certain cybersecurity control, how it will be realized. On the implementation level, yeah, I understand because my question itself was a bit confusing, as I told, because of course, at the end of the day, we know that system is consisting of software, hardware, which means even though you implement something in the hardware, you cannot say that it is not implemented in the system because hardware is a part of the system, right? At the end of the day. So in that sense, it is, but I was mostly talking from the logical levels, like I have a system, I have a software and hardware, but I think that kind of observation is not correct in this particular scenario. Okay, good. Any other remarks on this?
Also, other, I mean, on the same line, what Falgun mentioned, right? Like my view is that, like for example, there could be some control which may not need to be implemented itself.
Mhm.
For example, just to prevent physical access to the ECU, maybe I can place the ECU somewhere inside the car, which is not accessible. Maybe there is nothing to implement in the hardware software like that. Maybe it is just placing the ECU. Maybe this kind of thing also could be considered at this level. Right?
Okay, that is an interesting observation because with that I have another question. I don't have an answer, Ronak. Rather, I have a question. The question is, if at all there is something which is not implementable, do we still call it as a control? Because I was of the opinion that okay, control is something maybe you go and implement in the software or hardware or something. Ronak gave a good example that okay, maybe I just want to prevent, and preventing is maybe preventing issue from the physical accesses. Don't expose, rather place it somewhere inside the car so that it is not easily physically accessed. So can can we call it as a control or is it still a specification?
It depends, right? Now, the specific example that you took, yes, in the SPOF, no, not SPOF, I mean, in the whenever you get the risk, you either reduce the risk or prevent the risk or treat the risk
Or
or
pass
transfer
on,
the risk,
transfer.
transfer the risk, right? So in this section, you are saying that you are reducing the risk, right? You are reducing in terms of the statements. You are going to say, I'm reducing the exposure of the ECU or whatever the port physically. However,
Mm,
if you see it, you're actually controlling it. Because if you place this ECU in this particular case deep inside, unless somebody really breaks open the car, nobody can access that. So what would you consider this? Again, this is going to be a debatable topic. So are you going to consider this as a prevention or are you going to consider this as reduction? In my
okay.
perspective, it would still be a prevention because in order to get to this, you have to destroy the whole car.
Mm. Okay, then maybe I have another follow-up question. Maybe somebody who are very deep on Tara can answer this. Since there are four categories, either transfer or
Mm.
reduce or I don't know reject or whatever, whether whether all four of these lead to a control, or is it only one or two lead to a control? Maybe if I decide to reduce, then I need to define a control. If I need to reject, or if I decide to live with that risk, then I don't need to define a control. Do we have something like that in Tara?
Mm,
There is.
yeah,
There.
mainly, yeah, because if it's reduced and then only we can go for the requirement concept derivation or control
Hmm.
to selecting the control. If both the party agrees to live with that
Hmm.
risk, then I think no need to go further and derive the
Control.
concept or
Hmm.
control.
Hmm.
Even rejection part is the clear. Let's say they decided the limit uh, up to certain risks they can acceptable. Then
Hmm.
also they accept the risk. They don't go for the control. Uh, I think in the case only when it comes to the reduction part, then only while calculating the residual risk you have to take care about the control.
Okay. So even when transfer also we don't need to, which
No.
means
So again, transfer depends, right? Because when you transfer, you are transferring it from a system level to the software level. But the software guy should either do reduction, prevention, or
Yeah.
acceptance.
yes, I mean I'm mostly define staying in my scope. I mean I don't need
Okay.
to define a control, which means out of four, only one will
Mm.
result in a control. So in that case, I think the scenario what Ronak mentioned also comes in that one, which means that is a control, even though it is not implemented in the software. I mean, somebody has to put that ECU while designing the car inside the car, but yeah, okay. So that is also kind of a control. Okay, understood. Okay, colleagues, next best practice is best practice 4, refine interfaces. Refine and describe cybersecurity related interfaces between the elements of the architectural design and operating environment. I mean, when I look at it, it seems to be pretty straightforward. I don't see any, let's say, hidden things here. But the next one is really interesting because here I have some questions, which is BP5, which talks about analyze architectural design. And here the remark is analyze the architectural design to identify and analyze vulnerabilities, because this term vulnerability is something we hear often when it comes to cybersecurity. So maybe a question to the panel: what is a vulnerability?
Vulnerability, in my point of view, something once the design is ready, uh, the software is working, and then you later come to know that we have weak point here. Somebody can uh, exploit this particular component
Hmm.
in our design. Then it would become a vulnerability.
Hmm.
Uh, or let's say it's already exploit uh, while testing, uh,
Hmm.
and then again that is vulnerability that has to be fixed, I would say.
Hmm. Maybe a follow-up question, because this is something we have to really get it clear. So, if at all I find a problem
Mm.
which is related to the security, then do I call it as a vulnerability? If it is not related to security, then do I call it as a problem and handle as a part of the problem resolution?
In my opinion, yes. In normal process we call it as problem. You then handle it as a PRM, uh, and when it comes to the cybersecurity, we call it as vulnerability. So to answer your question, yes.
Hmm. Okay, so which means
So
uh, bugs or problems which are not security critical will be treated using whatever the processes which are defined in the ASPICE 3.1. But on the other hand, if at all it is a security critical part of the software or a system, then normally it is identified as a vulnerability and treated based on however vulnerability management is defined in the security standards. Falgun, you wanted to say something?
yeah, so as per ISO 21434, the definition of vulnerability is a weakness which can be exploited in the given attack path. So in this way, if your vulnerability is not coming in the attack path, or it not a weakness in the defined attack path, then it is not considered as vulnerability in the scope of cybersecurity 21434.
Um, can we have some examples, because it is bit hard to understand, because that's where also many of the cybersecurity engineers are getting confused. What is vulnerability? What is threat? What is an attack? What is a normal bug? What is a problem? And so on and so forth. So what can we think about some examples where I say, okay, this is vulnerability because this is a weak point in the way of attack path or in the attack path.
So let's say um, you have designed a system where there is an interaction between your ECU and another ECU,
Mm-hmm.
right? So there is a message exchange. For the sake of simplicity, let's put CAN.
Mm-hmm.
So it's on a CAN protocol. The message gets transferred between one ECU to another ECU. A threat is anyone can attack this message, anyone can modify this message.
Mm-hmm.
What could be the attack path here? The attack path would be that if the malicious intent person gets access to one of the ECUs or the channel itself, the physical channel where they can read out the CAN message, because CAN is a broadcast protocol, so you can still
Mm-hmm.
read out those CAN messages, so you can see that and they can put the message back into the network if this is a possibility. So this would be one of the attack paths.
Mm-hmm.
Now the weakness that your message is exposed, that there's content, the confidential content that one software is sending to another ECU, if it gets exposed, that is your vulnerability, because that is a weakness which can be exploited in the attack path. So this is a given attack path. The weakness is that if this confidential information is exposed, then your vulnerability is that your whole system can be compromised because that confidential information is out of the system. Also, there can be some let's say some more malicious messages that can be ingested into the network and into the system. So this is where it becomes a vulnerability.
Okay, in that sense, every attack path should have a vulnerability, right? Otherwise, what is the point of calling it as an attack path?
So let's say uh, we analyze the network and then we come up that there will be attack path. Let's say can messages are going through from one issue to another issue, and then attacker can somehow physically access this CAN bus, and then he can try to inject uh, CAN messages after reading it maliciously,
Hmm.
and the intended message cannot be delivered because the traffic is already blocked by the attacker. So in this case, I think let's say we decide okay, in order to prevent the read message, we can implement the CMAC, or let's say encrypt the message. In that case, even though it is breached, but the attacker cannot read the message.
Hmm.
But still, there will be a vulnerability if the encryption key somehow exposed.
Hmm.
So we initially prevented it by encrypting the message, but uh, let's say later point of time, if we come to know somehow this encrypted key also would be exposed and the symmetric encryption is means used, then it would be again dangerous.
Exactly. So that said, when are you finding it out? Maybe you do a penetration testing or some
Yes.
kind of a security related testing where you identify this
Hmm.
bug, or maybe you do the security analysis of your architecture or something like this, formal methods where you identify, okay, here there could be a weak point. Okay.
Yeah.
Now, if I compare, I take this complete scenario into a non-safety critical project, then what are they called?
They called as a problem, or
Problem
let's
or
say
a
bug
review
in it.
finding,
Yeah.
something which will treat it as a problem resolution, right? So,
Hmm.
from that sense, can we say that it is the same? But whenever I say vulnerability, I'm mostly talking about the security world. Can I say this,
Yes.
Falgun?
Yeah, this is what aligns with the definition that is given in 21434 as well, right?
Okay. So, which means, and also something I have observed, that the term vulnerability itself doesn't come into picture when we do Tara. It comes
Yeah.
after we finish Tara.
Hmm.
Like we have a process, according to that, I derived some requirements, controls, architecture is designed. Then when I try my verification method, both on the left side and right side of the V model, and I identify the weaknesses. I mean, here they give a beautiful term as weakness. Otherwise, we normally call it as a bug or a problem or I don't know, error, defect, whatever it is. Then normally it is called as vulnerability. Then it has to be treated according to the vulnerability management. I mean, we just want to be sure that we don't miss out any of these high priority issues without fixing. So it will be treated separately, but more or less it will be similar like handling the problems only, right? Because when we developed our product, um, car security, we had this discussion, if you remember, because a lot of the time there is a bit of a confusion, and engineers tend to think that vulnerability management is completely different, or how do I do it? Because everybody after one, because now I see that people are a bit familiar with Tara, so that they understand now what is threat, and how do I do the attack path, attack vector, these terminology they understand, but nobody understands where does this vulnerability come from. If at all I'm addressing all the threats already in Tara, then where is this vulnerability? I mean, in which part it comes? So this is where we had a longer discussion, try to understand, and when we try to map it to a non-safety critical, product development, we understand that it is nothing but a problem or a bug, but a security critical one. So that's why it is, different terminologies used, and yeah, that's it's treated according to the vulnerability management. Any other remarks here, colleagues?
No.
Okay. Uh, that said, we move on to the next one, BP6, which is about refine the details of the detailed design. The detailed design is refined based on the architectural design. Again, mostly we are referring to the cybersecurity part. Now, maybe a question to the panel. Let's imagine I'm, you know, refining my detailed design, and I'm also considering all the security aspects coming from the top level, from the maybe software architecture. Yeah. More often, we have had some scenarios in the project where I had a project where, okay, I can say, okay, these modules are non-security critical, these are security critical. But I also had some modules where some parts in the modules are non-security critical, maybe some functions are security critical. This was also the case in some projects. My question is, what is the best approach to design the detailed design in the security critical project, and what has to be taken care of?
So, in my opinion, there's this famous saying in functional safety, right? So, if you're not sure, make it safe. Better
Hmm.
safe than sorry. So, if your component, you said component or module, component. Let's say it as component has both security and non-security critical functions. It's better to make it secure.
Hmm.
Now, one other thing that I want to highlight is what exactly does it mean by making your component secure? How will you make your component secure?
Hmm.
Two ways. One, in fact, one way, you protect it. How do
Hmm.
you protect it? Protect it in two different ways. One, whatever the messages that are outgoing, protect that. That is by some kind of encryption. The second, whatever is inside your boundary, inside your component boundary, that also you need to protect. How would you protect it? You would protect it in a protected memory area. So you would define a specific memory area where your component resides, all your stack variables or all your uh, heap variables, whatever.
Hmm.
We are going in deep because this is unit design, right? So we are going in depth. So this is where you put it in a protected memory area. In fact, when you say protected memory area, so this is a area which needs some kind of authorization for non-critical applications to come,
Hmm.
so that they know that okay, this is some confidential information is stored there.
Hmm.
So if you are trying to implement a component which has both secure and non-secure functionalities,
Hmm.
I don't see much of a challenge in terms of efforts or the complexity where you place this component in this protected section. Of course, there can be some when it is interacting with other modules
Hmm.
where the operation might become really complex or really time consuming. So this is where there some architectural designs decisions needs to be taken. Otherwise, the best approach in my opinion is to always be safe than sorry. So put all the things in a critical application. Probably Ronak, do you have a lot of experience in designing these things, right? So what is your opinion?
So, I mean, as per my understanding, so uh, we are defining the assets and we are protecting the assets at the
Hmm.
end, right? So, I mean, if we tell these things are my asset, then maybe we are implementing some of the cybersecurity controls to protect that.
Hmm.
Uh, Now, if yeah, I mean, if the data set can be any module and so on, right? Then And then I just have to say, or I just have to find out how can I protect that asset,
Mm-hmm.
and then implement relevant control for that. I don't think it matters if that asset in one component or that asset is together with other non-security relevant things in some of the components.
Mm-hmm.
That's my understand.
Mm-hmm. Okay, so your approach is to make sure that, okay, as a part of the security related units, whatever the information we have to protect, we have to be careful about that, because sometimes when we mix up with non-security critical ones, we may also end up taking some verification methods which are not suitable for the security critical unit. So this is where I think the approach from Falcon is, if at all you have something security and non-security mixed up in one module, make sure that you verify everything according to the security standard, whatever the recommendations are there. Maybe do that kind of a coverage, that kind of a testing, that kind of a, security analysis, and so on and so forth. Understood.
And maybe just
Mhm,
to give one example about what I was talking about. So, for example, like we have any communication, Ethernet, or CAN, and so on, and we have hundreds of messages, but we are not protecting all the messages, right? We are just protecting some of the messages
mm,
which shall not be read by external people.
mm,
So I'm just protecting those assets which
mm,
are critical for me, and I'm not protecting everything.
mm. Understood.
Mm.
So let's go to the next base practice, which is develop software units. In this, we have the explanation: implement software using appropriate modeling or programming languages.
Mhm.
So, what is your opinion on this one?
Okay, so about the point, developing the software units which are security critical, what we need to understand is how do we see the difference between developing a non-security critical software units and developing a security critical software units, because it is always the dilemma for the developers. So far they have been developing a software where they didn't have to take anything, they didn't have to take care about any security related information, but now they have a project maybe where they're implementing or coding or modeling security critical software. Now I've always seen this kind of a question where I feel that most of the times developers overthink what has to be done. Very importantly, how do I, where do I get this feeling? I get this feeling when I see the difference when the functional safety standard was came. Because before that, there was nothing much to think about safety. People were developing, normal software, non-safety critical. Now came a standard ISO 26262, and everybody was wondering, okay, what should I do extra? Yeah, now I have to make sure that it has to be according to certain SE level. What should I need to do extra? The same question will also arise when somebody has not been working on security critical code so far, and now they have to deliver. Now question is, what do they overthink? They overthink, and the chances are that I have to do now completely different things. Yeah, so this is one of the misconception. People will think that, okay, now it is security critical, it's very very important. I have to make sure that everything works fine. There is no security breaches, etc., etc. There are no vulnerabilities, for example. For this, maybe standard says to do completely different things, which is not the case. Always important to understand that basics first. What are the basics? The basics is a spice, which means your quality standard. Irrespective of you are developing a safety critical code or you are developing a security critical code, a spice is the fundamental. You have to follow the quality process. What does the quality process mean? When it comes to developing the software, maybe use the proper template in order to develop the source code. Maybe use the right coding a language which is suitable for developing that kind of an application. Third, use the proper let's say rules such as misra rules or there is any other, customize his rules which are coming from the vehicle manufacturer, consider already while developing that particular code. Because normally we have a tendency that there are tools, static code analysis tools. Once I develop, I will, run it through the tool, and the tool will find out the warning, then I'll fix the warning, which is the wrong approach. Rather, I should already be aware of what are the basic things to take care when I, write the code. And, I may, then I, of course, I have to run through the static code analysis tool just to make sure that I didn't miss anything. But we shouldn't be relying on that. And also, the fourth thing is following the basic things. You have to initialize the variables. You have to make sure that there is no division by zero errors. For example, you comment properly, you trace properly. So all these things have to be taken care, very importantly. Okay, because if you go and look at the standard doesn't say anything more than that. Standard doesn't say that, okay, you have to do completely different things in order to develop the code according to the security standard. It doesn't say that. So the basics first. On top of that, what may also come is based on the security requirements or security controls what you have chosen, maybe you may need to implement certain security mechanisms in your code. These security mechanisms could be like handpicked, coming from vector stack, where you can take certain modules, configure it, and use it. Or sometimes it could be customized one, where you go with some dual storage, and you inverse it and you compare it to make sure that data is fresh. Or you may use some defensive programming techniques, etc., etc. So this is something you have to take care, which normally also comes with a bit of expertise, bit of experience doing certain things in the past projects. Or you can also take these qualities by trainings or something like this. But all in all, the gist is the basics first, and also not to overthink and do over engineering, and also not to expect that security would lead us to different things which we haven't done. Because in the past I used to take trainings for functional safety. Yeah, whenever I go and tell, hey, safety critical code, you have to do quality first, then you have to xyz things, they cannot believe it. They're like, this is it? I'm already doing all these things, then how different is it? They cannot believe that it's like, even when it comes to security, the less is more. It's not that you need to do a lot of things to make your software secure enough. That's not the case, because there are different mechanisms. It's not just that you take all the care during the implementation. You have a security analysis, you have the review mechanisms, you have penetration testing, first testing, you also do the unit testing on the code, etc., etc. So we shouldn't try to do everything in one process. Rather, it is distributed across. So if at all I don't find one issue here, maybe I'll find it in testing, something like that. That is how it is being done. So it is the complete approach, not to say that, okay, I have to do the, let's say, security secure coding, and it is something completely different than what I have done so far. So that shouldn't be the mindset.
So,
Any other
which
remarks?
means you mean to say that there's nothing new, but just some of the additional thing that we need to do on the top.
Exactly. Exactly. For example, I can still talk about one example, because if at all you are talking about normal embedded coding in automotive or safety critical one, let's imagine we are following the MISRA guideline. Now, when it comes to cybersecurity, you may have or you may use CERT guidelines, CERT, which are mostly the guideline for cybersecurity relevant,
Coding,
coding.
coding guidelines. Yeah.
So that would be the addition. But if you go inside CERT, these are also not the guideline which we don't understand. If you read through it, you will understand. These are the basic things or basic care you have to take while coding as a developer, in my opinion. Any further
Also,
remarks?
I think, yeah, so it's nothing new, it's the old one. And also, while choosing the language, we have to also think about, let's say, if you want to choose between C, C++, then I would suggest to go for C++, because
Hmm.
it has the security uh, provided within the language itself.
Hmm.
Let's say this classes and object and public, private, protected. These things you cannot do in C. If you use the C++, then you can secure some code using the you define the whatever you want to protect. So that is one thing. Other thing is, yeah, as you mentioned, the static code analysis. Also, while writing the code, you have to think about the underflow, overflow, this divide by zero, and those stuffs. So yeah, that's the only addition I would say.
I would believe otherwise. I mean, it's not like we need C++ or C++ is better. We can do all the things with C also. Like we can have static functions, static variables, which can be used to limit the scope and so on. So I think the same object-oriented model also could be implemented in C also. But yeah, of course, it could be more complex in implementation.
Yeah, it's purely based on the application, whatever the suitable language, because security can be taken care of irrespective of the languages. Okay, whenever I say irrespective of the languages, keep in mind that I'm talking about embedded programming languages. So yeah, but it's mostly also about the application.
So, a quick question on this base practice itself. What is the reason developed software unit is just identified as a base practice and not as a separate process?
Well, I mean, here the reason could be that if you look at the ASPICE 3.1, there also we don't have a separate process for unit construction. It is software detailed design and unit construction. It is a one process, and in that developed software unit is also one base practice. So mostly the same approach is taken even in this case. And yeah, I mean, if you see here, most of the things are merged into one process. Like here, there's architecture. It also talks about architecture, interfaces, allocating the requirements. So this is where I feel currently, this particular process, ASPICE for cybersecurity, is also not well elaborated. So maybe going forward, it could be a different uh, process altogether. The reason why I believe it will be or it could be a different process, because at the end of the day, when it comes to security, most of the things will come in the code, in the software. So there could be a lot more things we have to take care with respect to, how do I write the code, how the traceability should be, etc., etc. So I presume in a long run, these developed software units could also be a different process altogether based on how important the software part is.
Okay. So, let's move on to the next base practice, that is base practice 8, establish bidirectional traceability. So, this says establish bidirectional traceability between the refined architectural design and detailed design.
Okay, in my opinion, it's straightforward. So whichever the architecture designs you refine, the same if the detailed design are there, then bi-directional traceability shall be established between them.
Mm. Just to add on, once again, we have to think from the abstraction level perspective, because here I'm talking about the bidirectional traceability, of course, software architecture you have, then you also have the architecture in the system level. Of course, detailed design is only in the software level. It is not in the system level. So this is where again I feel that it is not clearly described, because it only talks about established bidirectional traceability between refined architectural design and the detailed design. Does that mean I don't need a bidirectional traceability between the cybersecurity requirement in the system level and cybersecurity architecture? It is not the case. So this is where we have to see what are the cybersecurity artifacts, and also it goes in the similar line. First comes the requirement, then the architecture. You trace from the architecture. In the software level, you derive the cybersecurity requirements. Then you go to the cybersecurity concept, which is nothing but the once again the architecture part, trace, then come to the unit design, trace, then come to the code and trace. So this is where again depends on where you work, in which abstraction level you work in, and to which work product you are responsible for. The scope changes with what you trace with. So that something has to be taken care of.
Anyone want to add on anything?
I think on
Mm,
that set,
no.
we can also add on the ensure consistency, the BP9, because they are more like coming
Mm,
together. Traceability supports consistency because we have talked in detail in one of the other video. How do we ensure the consistency? So here also once again, traceability is one thing to support, but we also need to do some additional things to make sure that okay, I do some kind of a review to verify that okay, my traced requirements in the architecture to the actual specification, they match. I mean, there is a it's a proper tracing. It's not just tracing for the sake of doing it, but the content also matches. It is the right kind of a traceability, and there is a consistency. This is also something we have to make sure.
So moving on to the last best practice, that is communicate agreed results of the cybersecurity implementation. So this says communicate the agreed results of the cybersecurity implementation to all affected parties, including stakeholders from post-development phases. What's your opinion on this point?
mm, okay, in my opinion, so during the vulnerability analysis, whichever the result we have, or whichever the agreed at certain level, let's say that the risk is acceptable, then all these things needs to be documented and also shall be communicated to all the relevant stakeholders.
Hmm.
So here
Okay.
it could be, I mean, all the artifacts maybe produced during this best practice, right? Like maybe I can have static code analysis results, or I have the code itself, and so on. Maybe all of those are communicated to the relevant stakeholders, maybe.
Mm. Yes, I mean there are. I see it in two different parts. One is until the development, what do you produce and how do you communicate to the different stakeholders? Which means, of course, if the supplier does something, it has to go back to the customer. If customer has something as an input, that has to be passed on to the supplier. And also, if at all I'm developing a product within the different departments, the cybersecurity related artifact has to be exchanged. So that is one thing. On the other thing, what we also need to remember is cybersecurity is not only until the development, there is also a scope for it after development until until the, let's say, end of, I wouldn't say end of production, um, until you call back the vehicle from the market. Yeah. So this is where there would also be certain informations which we have identified during the development phase that has to be passed on to the later stage, means for the after development or the post development. So that could be something like what Dharmesh mentioned. It could be the list of vulnerabilities that has been identified, maybe accepted. Yeah. Or it could also be any other information which would support the monitoring of the cybersecurity, related issues in the post development phase. Or it could be certain information that is helpful for the production phase. Yeah, something they have to take care, something they are not supposed to do, or something they have to you know shut down. For example, the debug ports, you use it during the development phase, but while going for production you have to close all of them because you don't want to keep it open for the external world. So this kind of inputs which also has to be given to the production so that they can take care of it, right? So this is where there has to be certain ways, or there has to be certain process how this information has to be exchanged This is very, very important, because what happens is, similar to the safety world, even the security critical informations are also very, very important, which means if at all somebody who is supposed to get that information, if they don't get that information on time, or they don't get that information correctly, then there could be a chance that your product may get, let's say, hacked, or somebody tries to attack the system and try to take control and to perform some malicious activity, and that can lead to a number of things. Yeah, we know the consequences. What are the 3 4 different type of consequences? The financial or the legal or whatever it is, operational, etc. So this is where this mechanism has to be clearly described during the project phase also. What are the information I'm producing, who is producing, and who has to get it. Yeah, and also with respect to the information of some security issues being found during the development, if at all supplier finds that information, who at the customer level is responsible to receive that information, who can also take certain action based on that, right? Because if the customer is going for vehicle testing, supplier identifies some security issue, and if it is not been informed to the right person at the customer side, and that, let's say, vehicle testing starts without having this information, there's a high chance that somebody may have get into some safety issues, yeah, because of some security issues. Yeah, so this is where we have to be careful. So this is more not to think only about just re- exchanging the result, but also having a mechanism to exchange the result so that we don't miss out passing on important information to the right person or the responsible person. So this is where again I say, this is also not something new. This is also coming from ASPICE. ASPICE says you need to have a communication matrix, which says who are the responsible people, what are their key roles, what kind of information I produce in this project, how do I share, how often I share, where do I share, etc., etc. The same thing has to be applied here. It is just that you take the basic, and on top of that you do some enhancement if at all it is required to meet the security world, but nothing to say that okay, I'm doing completely new things in the security world and I'm which I haven't done in the past. So that shouldn't be the thinking. Always the basic first, less is more. Take care of the proper quality standard, how they have been defined, like ASPICE level 3. Take care of all the best practices, generic practices, understand that, implement that, follow that, and on top of that, see if there is anything additional the ISO 21434 asks. Because if you see, ASPICE for cybersecurity, it doesn't ask anything additional, to be honest, other than some work products related to security. It doesn't say you do something completely different. So this is where we have to have a pragmatic approach, where I take what I have, the best practice in place so far, and on top of that I see what should be added or what should be taken care additionally from the cybersecurity perspective. So any other questions, colleagues, overall on this process?
None from my side.
Okay. I have a question which is related to one of the output work products. Yeah. Which is vulnerability analysis report. Yeah.
Hmm.
Can someone throw a bit light on what could this be? Because vulnerability we have understood, which is more of a weakness related to the security. And if we compare it with the, non-security world, it is nothing but the, problems you identify, uh, you know. But in the security world, we call it as vulnerability. So what comes to your mind when we think of vulnerability analysis report? How does it look like?
It's basically combination of problem analysis report and ICA we perform, like why it happened, what happens, and which stage. So it will involve in this report those things.
Mm-hmm. Yeah, I mean, it's see, because when we think about a report, this is also another thing. we have to learn, because sometimes when we look at the
Mm,
standard, we try to take it as is. Yeah. So it is written vulnerability analysis report. Oh no, now maybe I have to generate some kind of a report because that's what the artifact says. That's where we always say that it's important to understand and go a bit deeper. What is the purpose of this? So what happens in an normal projects which is not security critical? What did we do? We also had a problems there, and we analyzed those problems and we resolved, or sometimes we accepted, we decided not to resolve it because it is acceptable,
mm,
and xyz things like the bugs which are internally identified, findings which are internally identified coming from the customer. Either we populated everything in the Excel, we kept on updating it, or we also used some ticketing systems like Jira or ClickUp or Polarian, whatever it is. Similar way, when we talk about vulnerability analysis report, that could also be something like a ticketing system. Yeah, you can use the existing ticketing system. If at all you are using Jira, then continue to use Jira. But for the security critical tickets, maybe have a different label so that you can filter them out separately. That's important, because if you mix it up and you have to go inside every ticket to identify if it is a security critical or not, that is not a good approach. Rather, we should have a mechanism to segregate in one go what are all the security related tickets. Then we can use the same ticketing system. So at the end of the day, what will be the
mm,
report? When you segregate during an assessment, when you filter it out, you see that, okay, there were 50 issues and all the 50 issues have been, identified, analyzed, either rejected or, implemented and fixed. That itself will act like a report. So this is where, the hint is not to take something as is, rather to understand what is expected here and try to give it in some form, because standard also doesn't say vulnerability analysis report should be a PDF document. Standard doesn't say that. It's just that you have to give that content, but in some way. So what is some way? That's up to the organizations to decide. If they have some kind of a tool which is being used for the ticketing and all, they can use the same tool. They don't have to do something differently. So this is what I say, a pragmatic one. Otherwise everybody thinks that, okay, now we have a security critical project, all my developing environment is of no use, now I have to set up completely new to develop something security critical, which is not the case. So this is where use what you have in hand, and on top of that do some changes if at all necessary. Otherwise, whatever the things we have should be sufficient to also mostly develop all the security critical systems or software.